we are focusing on our CAN lab, but we are also focusing on this problem that I believe is helpful for our CAN lab and is also helpful in reviewing rational functions, which is what we've been doing so far. So we have spent a little bit of time just reading over this problem, reading the questions, and what we need to first determine is we want to find, or we want to express the height of our box as a function of x. So we know that x is the length of our width. Who can tell me the length of, or who can tell me what the depth of our box would be? It would be x, because we have a square base. Okay? We also have no top to our box. But we do know that its volume, our volume of our box, is 1,000 cubic centimeters. So if we know the volume of our box is 1,000 cubic centimeters, and we want to find something, we want to find this as a function of our height. What we would like to do here is, if we have the volume, how do we find the volume of a rectangular prism? It's like length times base times height, which is what I heard someone say. So I'm just going to use the wording they use here, which is width times depth times height. But it's the same thing as length times width times height. And what we want to do is we want to put this into an equation so we have h equals instead. And instead of having w and d, we want x's. So take 30 seconds, write this equation as h equals with h as a function of x. I'll pause the video while you work. We've got some time. Row 6, person 2. Could you tell us what you got? H equal 2. We've got 1,000 over x cubed. Okay. The x just stands for the w and the d, right? So it's just x squared. So here, instead of w and d, we have two x's, and x times x will give us x squared. Okay, we have our height. From our height, we want to graph it. We are graphing a rational function now. So if we graph a rational function, what's some important piece of information we need first? You have vertical asymptote. Can you give us another one? Another important piece of information we might need. We do indeed need the horizontal asymptote. What other information might we need? What do you think, Greta? If there's any holes. What else? Two other things that might be useful for us. Some intercepts, specifically which intercepts? X and Y intercepts. So take a few moments, find those important pieces of information. I will pause. Row 6, person 5 comes back up to Walt. Can you give us one piece of information?
I got the vertical asymptote is 0.
X equals 0 for a vertical asymptote. Would you like to call on somebody? Row 1, person 6 comes back up to Andrew. Y equals 0. Because if we look at our equation up here, bigger on bottom, so we've got Bob again, and Bob really likes zeros. Okay? Row 5, person 6, that'd be Quinn. Could you tell me another piece of information? No holes. Right, would you like to call on somebody? Okay. There are no x-intercepts. Because if we want an x-intercept, that means that h has to be equal to 0. And 1,000 divided by what will give us zeros? Nothing. You can't divide 1,000 by anything to get you 0. So we have no y-intercept, x-intercepts. And similarly, we also have no y-intercepts. Because if you substitute in 0 for x, what happens to your function? It explodes. It blows up. It crashes. Whichever way you like. All right. From here, we can graph it. If we are graphing this, we have our two intercepts, or sorry, excuse me, our two asymptotes. We have x equals 0, and we have y equals 0. And we don't have any other important pieces of information we need. However, we don't know whether we need to be in the positive or the negative quadrants, so we have to figure that out. How are we going to figure that out? Row 6, person 3. Can you tell us how we would figure out whether we need to be in the positive or the negative section here?
Plug in a negative number.
All right, and if we plug in a negative number, we end up with a positive or a negative height. Positive. So we're going to be up here. What about over here? Positive or negative? What do you think? Who thinks positive? Who thinks negative? All right, I'm seeing positive. It will indeed be positive, because if we just plug in like 2, that'll still give us a positive h. So we're going to be in the positive quadrant for both of our sides. So here we'll have one piece, and here we'll have the continuation of our function. Okay, from here, let's do a little bit of a review. If I wanted the limit notation of that behavior right there, what would that limit notation look like? Take a few moments, write down the limit notation. Remember the two little things we added this chapter that we did not have last unit. And I will pause while we work. If we look at this limit here, I just rolled doubles. Row 2, person 2. Abby, can you help us with our limit? Okay, goes to infinity. Remember the two little things that we changed, or that we added on to our limits. Is our x approaching 0 from the right-hand side or the left-hand side? Right-hand side. It's coming in from the right-hand side, so we have to have a positive above our 0. And then over here, is infinity a number we can count? It is not, so we need to add an arrowhead to our equal sign. Now, if we looked at this behavior instead on our graph, we would start the same, saying that the limit of our function does not need to be divided by anything. The limit of our function as x approaches some value, what value would x be approaching in this case? Infinity. And then what is the y value going to be as x continues to infinity? What is it getting closer to? With your fingers, show the number that it's going to approach. Is it going to approach 1, or 5, or 10? 0. It's going to approach 0. And can we count 0? We can. So you can write an equal sign, and you do not need the arrowhead, because you can count 0. Okay? Awesome. We've got our graph. Now what we want to do with our graph here, we have figured out our limits, and now we want to look at the surface area of our box. So if we are looking at the surface area, that's like the area of just the surface, right? And if we look at our box, we have a few little pieces that we have to put together, right? one of the pieces is just the base, which is down here. What would the area of that be? Just the base. X squared, just x times x. So we know that our surface area is equal to x times x, which is just x squared. And here we have 4 identical sides here. And what would those sides be? Think about it for a little second. I'll be right back. Oh my. Okay. If we think about our surface area, what will we need? What 2 things will we need to multiply together for each of those sides? H and x. Thank you. So if we need h and x, I'll put the x here. But what is h in terms of x? 1,000 divided by x squared. So here, if we put in 1,000 divided by x squared, this is just the same thing as h here. And how many sides did we have? 4. Exactly. So I'm going to put a 4 in front of the x because we have 4 of those sides. If we simplify this, we will end up with x squared plus, we can cancel out an x from each of those, so that'll give us 4,000 over x. Sweet. We have our surface area, but we want to find the minimum surface area. Yes, question. It would be 2x squared if we had a top to our box, but we don't have a top. Exactly. So we do not have a top, so it'll just be x squared for now. But at this point, we want to find the minimum surface area that we would need for our box. And to find the minimum, at this point, we cannot mathematically find it. You'll learn that in calculus. But right now, we can find it using our calculators. So if you would take a moment, take out your graphing calculators. If you do not have a graphing calculator, raise your hand. I have extras that I can give to you. And I will pause while we are handing out calculators. Now that we all have calculators, take a second and put our equation for surface area into your calculator. I will also be doing so up here on the board. So I have my own calculator. I'll move that out of the way. So, to put in an equation, I need to hit the y equals button. And from the y equals button, I'm just looking at y1 right here. And I need to plug in x squared plus, and then in parentheses, 4,000 divided by x. And once I've done that, if I hit enter, and then I go to my graph, my graph ended up looking pretty nice. Some of your graphs might not turn out this way. So let's take a second to kind of troubleshoot. If your graph just shows a very zoomed in version of this, so you're only seeing like a tiny bit of it on your screen, go to zoom and press 0, and then your graph will automatically look better. Mine actually looks worse, but yours would look better. If you're still having some problems and you're seeing like a lot more than what I was seeing, yours is like kind of making this kind of shape here, like that. Instead, you need to go to Window, and from Window you need to change your X min and your X max. So change your X min to -10, and change your X max to 10. And then go down to your y min and your y max, and also change those to -10 and 10 respectively. And once you have done that and you go back to your graph, you should end up with a nice graph. Mine is thinking. You'll get a nice graph that looks like how mine did. I will pause for a few minutes while we do some final troubleshooting with individual problems. Starting up a recording again, I need to go back to Zoom 0, and I need to get my graph looking like this. So you'll have one part of your graph is down in this quadrant 3, and one part of your graph is up in quadrant 1. That is what we need right now. If you have something in quadrant 2, don't worry about it. We're just focusing on quadrant 1 for today. Okay? So if we look at quadrant 1, what we want to find is we want to find the minimum. If we are looking for a minimum value, where should we be looking in quadrant 1? Should we be looking right here by 0? Is that a minimum? No, it's really tall. It's going off to infinity. We don't want to be here. We want to be, instead, as far right as we possibly can. So the way that we can calculate a minimum is our calculator will do it for us. So if you see the trace button on your calculator, if you go to second and then you hit that trace button, there's a blue button, there's a blue word up above and it says calc, and it'll help us calculate a few different items. We want to calculate the minimum, so I'm going to hit 3. And then it says left bound. All left bound means is we want the left-hand side of where you think the minimum might start. So I'm just going to make sure that I can see my marker. I have a black marker on mine. You might have something similar on yours, but there's some kind of marker that moves when you click on the keys. And I'm just going to move that marker until I can see it, and I'm just going to hit enter. And then it asks me right bound. So for right bound, I want to find the right-hand side where I think the minimum might end. If I keep on clicking on the right-hand side, on the bottom of your screen here, it gives you an x value and it gives you a y value. If we want our y value to be minimum, what we want to do is we want to keep on arrowing over to the right until our y value doesn't decrease anymore. So right now my y value is continuing to decrease. I'm at like 800 now. I just dipped down into the 700s. Now I'm at 711. Now I'm at like 650. And I'm just going to keep on going down. I'm in the 500s now, so it just keeps on going. But after a while, particularly for this problem, once you get into the 400s, you'll notice it gets to around 480, then 470, then 460. Hold on 1 second. I'm going to pause in my clicking here. Here's the mark. Unblock it.
Oh.
Okay, I'm in my 480s. But at one point when I was clicking, I was at 477 or 476. And then I started increasing to like 470, 480. So it started going up again. Because it started going up again, I know, oh, my minimum must be somewhere in there that I already passed. If I already passed it, all I have to do then is just press enter. And I know that I already passed it, so my minimum is going to be somewhere in between there. Then it says, what's your best guess? It doesn't really care about your guess, so just press enter. And then it'll give you your minimum value. The minimum value I got was x is equal to 12.6-ish. Show of hands, I also got 12.6-ish. Somewhere around there. Okay, cool. So we have our minimum value for x, or for our width. And because our y value was the surface area, your surface area would end up being around 476-ish. So we found our minimum. You might be wondering, why does this matter? For your CAN lab, you might need to find some kind of minimum, but you will definitely need to calculate the surface area of your CAN. So if we transition now to the CAN lab, if you could pull up the data that you already have for the CAN lab. Show of hands, I was not here for the start of the CAN lab. I have no idea what you're talking about. If you are not here, now is a perfect time to ask the person in front of you or behind you, hello, I was not here for the CAN lab. May I please have your data? Okay. Once you have your CAN lab open, it looks something kind of like this. And you have a data table here. What we are doing for the rest of the day is we are going to make your lives 10 times easier so you do not have to plug in 20 different calculations into your calculator. Instead, we will be using Excel or Google Sheets and have it do the calculations for us. Okay? Before we do any of those calculations, though, we need two pieces of information. The two pieces of information that we need are, how do you find the volume of a cylinder or a cylindrical prism? And how do you find the, what is it called? The surface area of a cylinder. So, if we are looking first at the surface area, what's one thing that we need for surface area? Exactly. So we need the area of the circles, and there are two circles, so we need two of those areas. So I'm just going to put an area, an A for area, and then I'm going to draw a circle next to it, because it's the area of a circle. And what else do we need for surface area? We need the area of the surface of the side that goes around. So how do you find that? The circumference of your circle times the height. All right, if we look at this, we have the surface area is equal to 2 times the area of a circle. What's the area of a circle? Pi r squared. And then we need the circumference of a circle. The way that I remember circumference of a circle is twinkle, twinkle, little star, circumference of a circle, 2 pi r. You can remember it that way. Otherwise, it's just pi d, which is how you might have learned it. I'm going to write it as 2 pi r here, because did we measure the radius or the diameter of our cans? The radius. So we need a radius, so I'm going to keep it like this. So we have 2 pi r and h, which is our height. So now we have our surface area, but we need our volume now. Does anybody remember what the volume of a cylinder is? Exactly. It's just the area of our base times the height. Thank you, William. So now we have our volume, we have our surface area, and we can put these equations into Excel for us, and it'll calculate for us. So, right now, I would like you, once you have written down these two equations, the surface area and the volume, to either get onto Excel or to get onto Google Sheets, whichever one you downloaded. I will be using Excel, but you may use either of those, and it should work the same. And the first thing that I want to do is I want to set up a data table just like the one that we had on our CAN lab. So the first thing that I want is the brand name of the can. I'm just going to put brand name. In my second column, I'm going to put height. It might be height or radius for you, but it's going to be in centimeters. So if you have it currently in inches, you need to convert to centimeters. Then I will have the radius, which is also in centimeters. And then I will have my surface area. And surface area, the units of surface area, since it's an area, would be centimeters squared. But Excel doesn't really give us the superscript, subscript. At least it doesn't on the iPad. So if you just put a caret and then a 2, that means the same thing. And then our fifth column here, we would like to be the volume, which has units of cubic centimeters, or centimeters, and then a caret, and then a 3. So take a few moments, write down these 5 columns on your Excel spreadsheet or on your Google Sheet. And after this, we actually have 2 more columns. If you already have these 5 written down and you're just waiting for people, it would be a great time to get all of your data put into this Excel spreadsheet. I see that most people are done with these first 5 columns. So I am going to scroll over to the right and add the next 2 columns. So the column that I would like here would be the surface area divided by the volume. And then the final column I would like would be your height of your can divided by the radius of your can. So those are our 7 different columns. And what I would like to show you is a cool way that will let Excel automatically calculate for you. So someone who is done looking at or writing these 7 columns, could you give me your can? One of your examples, Greta. Okay, so we got chicken. What was the height of that can?
10.9.
We've got 10.9 centimeters, and what was the radius?
3.5.
Thank you. So here we have a chicken broth can. I guess I should write chicken broth so that we don't think we're canning chicken anymore. So we have chicken broth. We have the height and the radius of that can. And if we want to find the surface area, we know what the equation was. So we just have to put it in to Excel. So to put it into Excel, we start with an equal sign because we have an equation, and equations always have equal signs. And surface area, we started the surface area with the area of our circles. And there were 2 circles, right? So we started with 2, since there were 2 of them. And then times, which is just the asterisk button on your keyboard. And if we have the area of a circle is pi r squared. So the next thing we need is a pi. If you just type in pi, it'll put in a value for pi. If you're using Google Sheets, I believe you might need parentheses after the pi, but I do not know 100% for sure. So just try it with just pi right now. And then we need to multiply that by r. But r, we can't just write r. We need a value for r. And we have the value for r. Right? So here I have a value for r. So if you just touch it on your iPad, what's going to pop up in your equation is the cell that that number is in. So for me, that radius is in C3, so it just pops up as C3. And then I want to square that. So to square, you have to use that caret button, and then just press 2. It will square it for you. Okay, that's the first part of my equation. Next in my equation, I need to add the surface area of the main body of my cylinder, which is just the circumference of a circle times the height. So circumference of a circle, 2 times pi times, and then I need another r. So I can just click on my r again, and it'll give it to me. And then I need to also multiply that by the height. And the height is over here in B3 for me. So if I just click on it. It'll show up in my equation. And once I have that entire equation written out, if I just press return or enter, it'll automatically calculate it for me, supposedly. I say supposedly here.
Just change pi to click down below on
It should. Let's see if this will work. Okay. So in Excel, if you have pi and you type in pi, you can either tap on that scroll down that says pi, or just add parentheses after pi. So you need to open parentheses and close parentheses after pi, and then pi will work on your Excel. You will also need to do the same thing in Google Sheets. Thank you for the feedback. Okay, now I've got a surface area. Awesome. You might be wondering, that is so much effort. Why would I ever want to do that? Here's the great thing, okay? This is definitely not wrong, because Excel will not make it wrong. But the other thing is, if you take this cell where you just finished creating that equation, and you copy it, and you paste it on your second can someone give me one of their cans? A second can that they had. Who here can give me just one of the cans they had? I just need the height and the radius of their second can. Come on. Bobby, did you have a second can that you can use?
Yeah.
Okay. It's all good. Actually, you can convert into centimeters on Excel too. If you want to give it to me in inches, you can. I'm just going to go here, and I'm going to use an equation again, and I'm going to say equals, and then if you give it to me in inches,
4 inches.
if you have 4 inches to centimeters, you need to multiply it by 2.54. So if I multiply this by 2.54 and press enter, I have it in centimeters now. What was the radius of your can?
1.25.
We have 1.25 inches times 2.54. That is 3.175. And look, because I copied and pasted my formula from here to here, it automatically calculates it with the new values I have. This way, you don't have to put in a whole bunch of different calculations into your calculator. You can write it once in Excel, copy and paste it, and however many cans you have. For all 3 cans, you only have to do the calculation once, and then it's just copying and pasting from there. On your own, you're going to need to be able to write the equation for the volume, and you need to then write the equation for surface area divided by volume, which sounds hard, but isn't surface area divided by volume, don't we have columns for surface area and volume? So all you need to do is you just need to press the equals button, and then you can just touch surface area, and then you just need to divide it, and then you just need to press wherever your volume is, and then if you press enter, there you go. Calculation done. Right now, mine says that because it's dividing by 0, because I have no number in my column. But if I put a number in there, say I put 1,000 in there, it won't actually be 1,000. But if I put 1,000 in there, it'll create a value. So that is all we're doing today. That is the Can Lab. That is the magic of Excel and Google Sheets. It gives you calculations without you having to work too hard on it. I apologize that today was a math-heavy day, but I would rather do that now than on Monday first thing. Question about this?
Oh yeah, what's the Can Lab do?
The Can Lab will be due Thursday after we come back from Thanksgiving. Thursday after Thanksgiving. When is our test for rational functions? Wednesday after Thanksgiving. Make sure to return your calculator if you borrowed one and take your collateral. But that is all the material we are going with for now, so I will stop the recording here.